Okay, now we're on page 92. We're going to look at some different sampling methods. I'm going to pull over and look at some PowerPoint videos from the Mario Triola 13th edition. I will post that in full, as well as just some extra resources, so you don't need to write everything down, but if you want to jot down a few things from that are key elements, and then you could probably go through and do this as classwork. I'll go over a few concepts here though first. So we're looking at sampling methods. So the first thing we should do before conducting the survey is to identify the population. We want to really try to avoid any bias or errors in our sampling. Sampling bias occurs if every member of the population does not have an equal likelihood of being in the sample. So for instance, if I just asked my first 5 students on my roster a question about the course, am I getting good feedback? No, because everyone else was excluded. So it doesn't give a good sampling. They may have an entirely different opinion, especially if it's like, oh, the first 5 people who signed up for the course, like, oh, I'm just going to sample them. That might be very different than the last 5 people. So example 8.5 gives a little scenario and talks about some possible sampling biases. Now, if you've read the textbook already, you might be able to answer that right off the bat, but I think you'll have a better idea when I go over it in the PowerPoint as well, because these notes are kind of sparse. Also, what we're trying to do here, another definition, is when each member of the population has an equal probability of being chosen. This is called a random sample. If every member of the population of any group of members has an equal probability of being chosen, then it is called a simple random sample. Okay, so we're going to look at example 8.6 here. If we identify all likely voters in a state and put each of their names on a piece of paper, toss it into slips in a very large hat, draw 1,000 slips, then we would have a random sample. And the answer to that is true. I'll tip these in later, but I want you to compare that to the scenario given above. Also, if I ask the class, like I could just do the whole population of my class. I don't really need to take a sample. It's not that big, but what I could do if I had a whole bunch of classes, I could take and just do a random number generator, give each one of them a number, and have it spit out like 100 students out of, like, say I had 1,000. So those are some techniques we use. I want you to go back and fill in this one, example 8.5, after I go over the video here, not video, but the PowerPoint. So the resource I'm just using a little bit of it. You can use about 10% of other sources without having to have it be, part of our course requirement. So this one here is from Elementary Statistics, Mario Triola. We use it for Math 146 a lot. So here's all the info about that text. So I'm going to just skip down to some of the things here that will pertain to samples, and let's see here. And that can cause us problems. So here's a voluntary response sample or a self-selected sample. That's one in which the respondents themselves decide whether to be included, and that can cause a variety of problems for different reasons. But if you think about it, like, you have to be willing to do it, so it may, skew the results because those people could have a different opinion. So the kind of polls that are given a lot of times are seriously flawed, because we should not make conclusions about a population on the basis of samples with a strong possibility of bias. So internet polls, mail-in polls, telephone call-in polls, like radio show things, and things like that. So here's an example. Nightline is a show that asked viewers to call with their opinion about whether the UN headquarters should remain in the United States. Viewers then decided themselves whether to call with their opinions, and 67% of the 186,000 respondents said that the UN should be moved out of the United States. In a separate independent survey, 500, so a lot less, were randomly selected and surveyed, and 38% of this group wanted the UN to move out of the United States. The two polls produced dramatically different results. So even though the Nightline poll had way more people, it was a volunteer response. So the other smaller poll was much better because it had better sampling methods. So a lot of times in statistics we say the study's only as good as the sampling. So right then and there, if you're reading, we're just covering like statistical literacy and like how you can interpret things. So if you're watching something on the news or reading it in the paper, then notice, or especially on like Facebook or something, notice how was that sample taken? Is there a vested interest? We'll look at some of those things too, like is it self-serving? Is it a good poll? Is it a limited sample? Did everyone get a chance to participate? And things like that. So I'm going to skip this part for now. So here's analyzing data, potential pitfalls. So misleading conclusions. So you need to be really careful when forming a conclusion based on a statistical analysis. We want to make statements that are clear, even to those who have no understanding of statistics and its terminology. So you want to put it into lay terms if you're writing a paper. Sample data reported instead of measured. So in collecting data from people, it is better to take measurements yourself instead of asking subjects to report results. And a lot of times it's much more convenient to just do a survey or something like that. But if at all possible, if you can just get that data by observation even, or doing an experiment. Loaded questions. If survey results are not worded carefully, the results of a study can be misleading. It could just be as much as you saying one thing first, like reversing the order of how the sentence is presented can make a big difference. Or if you have a negative viewpoint on something and that shows in the question, that could skew the results. I was just talking about order of questions. Non-response, when someone either refuses to respond or is unavailable, and there's lots of reasons. Sometimes it's going to violate trust. You know, they don't want to admit to something. These are all in your book too. It might be worded or titled a little bit differently. So if there's ever a quiz or something like that, questions, just make sure you describe what you're talking about. So you may not have the title right, but you have the idea right, and that's fine for me. Percentages, this one I didn't see in your book, but some studies cite misleading percentages. Note that 100% of some quantity is all of it. But if there are references made to percentages that exceed 100%, such references are often not justified. Okay, so that's it for the PowerPoint for now. We'll go back to the paper. Okay, so now you can see here where we have the answer to 8.5. There could be a variety of answers. If I ask you to say, you know, maybe one thing, there could be a few different good answers. This is a small sample, which isn't necessarily really bad, but it's a limited, I should maybe say, limited sample, in that It only includes people who subscribe to the digest. It's also a volunteer sample. This one we already talked about. So now let's look at page 93. We have the natural variation in samples. Sometimes we have sampling variability. So that's okay to have a little bit of that. For example, if we look at example 8.7 here, if we repeatedly take samples of 1,000 people from a population of likely voters from Washington state, some of these samples might have a slightly higher percentage of Democrats or Republicans than the actual amount in the general population. Some samples might include more older people and some might include more younger people. That's sampling variability, and a little bit of that is just fine. Other sampling methods that we have that are good to use, but sometimes can have issues as well. The best method is the just simple random sampling that you can just do a random number generator, or like the pieces of paper and a hat kind of idea, but we would use technology instead. But that's not always possible. And sometimes we want to make sure we do have things balanced out for various reasons. So here's one that is a good one. Stratified sampling. We divide the population into subgroups, and then we take random samples from each subgroup so that we have proportional sizes. So if you were looking at, okay, we're going to look at all 50 states, and I'm going to take 10, people, probably more than that, or 1,000 people, 100,000 people, whatever, from each state, that would be stratified. But I'm going to compare that down here to cluster sampling. And in cluster sampling, we would just pick certain clusters of states and then sample everybody in those states. So that's the difference. And on the PowerPoint, I'll show you, you'll see some pictures. Quota sampling is a variation of stratified, where we want to make sure that we have a certain quota or ratio of people. Systematic sampling is when we do like every third person for down the line, like in the class, I would pick every third person on the roster. Convenient sampling would be something like I'm just asking people I have easy access to, like Facebook is typical. Voluntary response, we talked about that. It's allowing the sample to volunteer, so you don't know for sure if they'll even respond or respond accurately. So here are some examples. Example 8.8 has a variety here. So see if you can identify using just from the list above, although there are other things that we'll look at in the PowerPoint, but see if you can figure out what these are before we move on. And I will type in the answers so you can check that. And then before I do that, actually, we're going to just quick go over here because we talked about this in the PowerPoint already, how to mess things up, like problems and errors, and we'll talk more about that in the next PowerPoint. But sampling bias is a sample that is not representative of the population that we looked at a little while back. It could be voluntary response bias, is a specific type of sampling bias. We talked about that already. Self-interest is when the researchers have a vested interest, like we think about the sugar company when, they were, when my kids were little, they said, oh, sugar doesn't make kids hyper. Well, it made my kids hyper. Response bias is where they give an inaccurate response, whether they intend to do that or they just don't remember, like a lot of like food reporting kind of things. People tend to underreport what they eat. Perceived lack of anonymity. So if it's, I know your name, and you're putting in something, you don't want to answer that, like, did you do drugs today? And you're in a classroom like that, is probably not something you're going to answer accurately. Maybe some people will. Loaded questions, it's when you have the wording and how it is presented. So you'll see some examples of that. And when you do this example and try it, and maybe you're right, maybe you're incorrect, but when you look at the right answer, you'll see, oh, now I see. But there could be a couple of different choices. So just know that sometimes there's a little wiggle room, and on a quiz, definitely write out your reasoning. A non-response bias is when they just refuse to participate. So we don't get that data. So here's example 8.9 that I would like you to pause the video and try, and then I'll just type the answers in, and then we can go over that together. And I think I am going to actually split this video up. It's getting long, so I'm going to stop here, and then I'll pull in another PowerPoint, and we'll just have 3 parts to this chapter. But I'll put the answers up first before I do that. Okay, just a quick another couple of minutes so that we can get the answers here for you, and then the pictures for the sampling that I promised from the PowerPoint. So here's example 8.8. If you go back to page 93, A is systematic, B is stratified, or it could be quota because it's kind of specific in a ratio. Viewers of a new TV show has to vote. That's C, voluntary response. D, simple random, or it could be convenience maybe because it's their website and their customers, so it's pretty convenient. Survey voters in a town, E, cluster sampling. Now let's look at example 8.9 on the next page. You have A is response bias, B is sampling bias or voluntary response bias, C is sampling bias, because not everyone has equal chance to be chosen. D is lack of anonymity, E, self-interest, and F is loaded question. Now again, these might have a different answer that would work as well, but those seem to be the best fit. So I do want to pull over this PowerPoint real quick and just show you some of the what systematic sampling is. So this is a picture. This is again from the Triola book. So you pick a starting point and then do like every third. So there's a picture depicting that. Convenient sampling, a lot of times it's just surveys or people that, you know, oh, I'm going to survey people in my class, you know, that's convenient. Stratified is where you have 2 groups or 3. You could have more, actually, it's at least 2 or more, and then you're going to pick the same number from each group. But if you do a quota, you can vary that and do like a proportion of them. It doesn't have to be exactly the same number, but it would be the same proportion. So if you did 3 men and 4 women from one of the group, you would do 3 men and 4 women from all the groups. Cluster sampling, you're going to divide the population into sections, and then you're going to choose all the people in those clusters. Multi-stage is when you have a combination. So that's it for the sampling on this video, and we'll probably hit through it again in some regards in the next couple of sections, and then we'll be done with this chapter.